It seems that diagnosing the fuel gauge to these square body trucks is a black art, but it really shouldn't be. Got a factory gauge, and if you notice on the back of the factory gauge, what you'll find is a little resistor like this, a porcelain resistor. I'll take it off, put it on the test bench, and put test leads to it. And, well, it should be 90 ohms, thereabouts. And this one is still infinity. So what we have is a bad resistor. So we remove the resistor and we test it and we know it's bad. But how do we arrive at that conclusion? And what did we do test-wise? Well, probably it's best to go over the basics of how the system actually works. On top of the gas tank, you have the fuel sender unit and the fuel lines where they all connect. This normally connects via a snap-on connector to the sender unit itself, and then this connects to the body of the unit and grounds it to the frame. Very commonly, the ground, which goes down and through a hole in the frame to the inside of the frame rail, the inside of the C down there, where you can access it. The ground goes bad, it gets rusty, and the ground goes bad, and that can cause all kinds of weird, erratic meter behavior, especially if the ground is an intermittent type connection. So it'll have resistance when it should be 0 ohms. So that'll mess up with the reading in one way, but then if sometimes it gets good connection and sometimes it doesn't, as it vibrates down the road, your gas gauge can go all nuts, right? These connectors here will often corrode. So a little brass connector in there, and they'll lose spring tension and they'll corrode. So you can clean it, a little rolled up 400 grit sandpaper into a little tube, or get a drill bit that's about that same size, and you can use it to scrape it out in conjunction. You can also use like MAF cleaner, sensor, mass airflow sensor cleaner, electromotive cleanser, brake clean. Any of those will be good enough to clean that off without causing any problems. So clean it off really, really well. And if you have to, squeeze it with a little pair of dikes or needle nose pliers just to get a little extra spring tension on there, and clip it on. You could always replace it too, but hey, I'm cheap. What are you going to do? Same thing with this connector. If you're going to replace your sending unit, which I recommend, if you've gone to the trouble of dropping the tank, it's not a bad idea to replace it. This is a gas sending unit for a GM square body truck. This one has I'm going to knock it out of the vise, has an attached ground strap, and it is been soldered on. The connector's been soldered on, because that off is another source of corrosion and bad connection right there. So they use a spade connector, but they put a dab of solder on it. Here's the float. This is one of the things that goes bad, the float or the rheostat here, in old fuel sending units, right? In the empty version, it ought to be like 1 ohm or less, effectively a short to ground. And then when it's full, it should be about 90 ohms. When it floats up like this, it should read like 90 ohms. You can confirm that by measuring between this pin, brass colored pin, which is your signal lead out, and the ground. Now, it would be the height of folly to install one of these new units without testing to make sure it's not defective, because the gas tank is really hard to get to, and this access point is actually under the cab, so you have to drop the tank down to even approach changing it out. So through the magic of alligator clip test leads, I've got that hooked up, and it says it's 1.5 ohms, which is probably good enough for government work, and you lift it up and it's 91 ohms. So this is close enough to being in spec to be perfectly fine. So how does the circuit actually work? It's sort of a differential comparator of some sort. It's got a reference resistance, right, which when you apply voltage to it will give you a reference current, and that flows through one coil in the meter, and then you have another one that flows through a different coil in the meter that is the resistance, and therefore the current flow is controlled by the variable resistance of the sending unit, varying from a less than 1 ohm or 1 ohm to 90 ohms or thereabouts. Now, how to diagnose the sender unit and, well, much of the other circuitry as well. If you ground this out, it's the same as the gas tank being empty, and it should go all the way to the empty side. If you take this off, it's the same as much more than 90 ohms, infinite resistance. Well, the gas gauge, it won't just go to the full mark. It will go well past the full mark. Like the mechanism bottoms out at around the 3 o'clock position, if you imagine it like a clock face. So if you take this off and the meter doesn't move, then it could be something very, very wrong. The meter could be very badly damaged, or the wiring could be a suspect. Right? Maybe there's, the wiring is messed up between here and the dash. That would be something to look into. The way the dash plugs in, I'll show you the dash plug in a minute. There can also be some flakiness there, depending on the age and the condition of the. I hesitate to call it a printed circuit board, but I'll show it to you in a minute. So if we take this off, it goes past full. If we ground it out, it goes to empty, right? Easy enough. The ground connection, we should automatically assume it's bad. Go to the frame rail, take the screw off, clean it, the ground contact and the frame where it contacts to, and then reassemble. Always just verify the ground connection by cleaning it. This is the dreaded instrument cluster connector. For anyone that's had trouble working on one of these, it connects to the back of the instrument cluster. Okay, this is what the back of an instrument cluster from one of these trucks looks like. This is a thin plastic printed circuit thing instead of point-to-point wiring. They're pretty durable and they hold up. That being said, if you have problems with weird connectivity issues, it's probably here, this plug. It should be not corroded. These can be cleaned, like a Q-tip and a little bit of electromotive solvent of some kind, like electrical contact cleaner, something like that. Just spray some into a cap or a little container and use a Q-tip to dab it in there. Be wary of spraying it where it can get into the plastic, because who knows what it'll do to the plastic depending on what kind of solvents are in it. Couple things to note on removing this. That is the main connector. There's another connector here, right? That just takes a two wire plug. And there's the mechanical speedo connector, which if you look at the side, has this like sheet metal spring. Basically, you push on this and you slide the connector over the top and it'll latch. So when you're putting it back into the truck, when you're taking it out, you reach your hand in there. Hopefully you have small hands, unlike my meat hooks, and you pull that, you depress that, and it'll allow the speedo to slide right out. And it's a square drive, or some type of square-ish drive in there, and it has to kind of be rotated and lined up right. So, you might have to jiggle the cable a little bit to get it to actually line up and go in. Kind of like putting a distributor in. You got to stab it in with the slot lined up. Well, this is sort of the same thing. But that's how you do it. You don't yank on it without pulling this back, because it's really light pressure to depress this clip, really. But it has a surprising tenacity when it's not depressed and unlatched. It holds it on there tight. You're going to bust stuff if you try and yank it out. So be very careful. These are light bulbs, right? And this is the connector for the light bulbs. It's like that shoddy. So if you have one of these that don't work, do the same thing. Clean it up, right? Make sure that the material isn't broken. If this gets broken or scratched, then there are ways to patch that, but you don't want to be involved in that, trust me. So be careful with all this. Don't mess it up. This is where your meter is, but you access the meter through the front side by removing the meter itself, right? So you don't get anything through the back of this. So don't be tempted. Also, you've got an automatic transmission. Make sure you disconnect the wire that does your park and drive and reverse and all that indicator, your gear indicator. It's just a Rube Goldberg affair, a wire that goes over a pulley that connects to this plastic thing on the other side. So be careful that you don't bust that. You got to take that off before you remove this cluster, or you'll bust it up. Okay, we've seen that you accessed the resistor from the other side of the gauge. Remove the gauge and pop it off the back. There'll be a couple of little sheet metal screws like that, or sheet metal nuts that hold it in place, and that's how you remove that, and you can test it. And this one tests as an open, infinite resistance, no good. So what do you replace it with? You can buy these. They're, if you can find somebody that has one, they're 25 to 35 bucks, depending on how bad they want to screw. And it must be hard to get a hold of these, I guess. They can be hard to find. Not every place will have them. What I'm doing is I got regular resistors, and I'm just going to use a couple of resistors in parallel to get the right resistance, and I'll solder them in. Behind the gauge in here, there's plenty of room. There's a big open area that's just air, and there's plenty of room for a real resistor. You don't need something that's like a little tiny like this. You can't just use a tiny little resistor like a little one you'd find in a radio. It's not going to be enough wattage. This is porcelain like this for a reason, because it gets hot. It dissipates a significant amount of current, and that generates heat. So what I'm getting are ceramic resistors. They sell them at several online providers. You can get them from Parts Express, you can get them from DigiKey, you can get them from Mauser, and they're used in all kinds of equipment. You want like a 5-watt ceramic resistor. It might be tough to find 90 ohms, but if you get two 180 ohm resistors and you wire them in parallel, which means you hook the leads together on both sides, and then you take those resultant leads and hook it to your meter, it'll work fine. So what I will do is I will wire them in such fashion, in parallel. So two 180 ohm resistors wired in parallel turn into a 90 ohm resistor with twice the wattage, so I'll have 10 watts of dissipation capacity, which should be more than enough. And then I'll put ring connectors on the ends of those two leads, put some shrink wrapping so they don't short out against anything, and then I'll put them on the terminals of the gauge and reinstall the nuts that held the factory one in place, and should be good to go. That should be it. So if the sensor's bad in the tank, all kinds of bad things can happen. As far as the reading goes. If the gauge doesn't move at all, suspect wiring, suspect maybe this guy, suspect maybe the gauge mechanism itself. If when you disconnect the sending wire on the gas tank, it goes all the way to the 3 o'clock position, that's usually an indication that the gauge is working correctly. That's what it's supposed to do. And if you short that out to 0, it should go all the way down to empty. And if what happens is it acts totally normal, what mine did, it acts totally normal, but it just would come up to a quarter of a tank, or sometimes maybe a half a tank, and then it would just stay. And that was it. It would just, no matter what kind of gas level you had, it would be around in that range. It would vary a little bit, but not very much. So things to check in my instance, the first thing I looked at was the sending unit was good. The ground was also good. Turned out the resistor in the back, bad. So when you have normal gauge behavior, when you ground it or open the circuit, right, it goes all the way full or past full, and then goes all the way down to empty. So the gauge is working and responding and moving, but it just is nonsensical readings. Then this is the likely culprit, this little resistor back there. And it's easy enough to test it. Just pop it out, put your multimeter on it. So I hope that was helpful, and see you next time.